In this video, I'll be showing you how a relay works and how to use one yourself. Just do me a favor, hit the like and subscribe button for the algorithm. Let's get started. First off, before we use a relay, we have to understand how it works. Inside this relay, there's a switch and a magnet, and the magnet can be activated with electricity, which then moves the switch and allows us to control power without actually having to use our hands. Now, just so you understand, I have a demo here. This is called a linear actuator, and when I give it power, it activates an electromagnet in here and then moves this rod back and forth. Now imagine if this was here and then we had an actual switch and that went and flicked on and off. It works similar to that. Obviously it has to be compacted and a little bit more efficient so that it can fit in such a small unit. So it allows us to use low power to control high power things. Because otherwise, if you can control your lamp with an Arduino, you would just plug your lamp into here, turn your lamp on and off. With your Arduino, you wouldn't have to use any of this stuff, but the lamp needs so much power that this Arduino will never be able to provide without something like this. So we get our power from somewhere else, but we still use a relay to switch it on and off. It lets us delegate our power source, but it doesn't make us lose control of if the power is being activated or not. On the left, we have our power side, and on the right, we have our control side. Our control side uses low power, like 5 volts or 3.3, to control the relay, whereas the power side, as you'll see on top here, you'll see numbers, and this one can take 10 amps and 30 volts DC or 250 volts AC, which is a lot for something this small. So just off these numbers, I could actually control my laptop charger, a lamp, the fan in my room. All these things that take a decent amount of power can be controlled just by one of these, and this was like less than $1 off of some cheap website. So for the power side, we have NO, COM, and NC. Mine are kind of cut off, but NO stands for normally open, NC stands for normally closed, and the middle COM is for the common ground. So what happens is you put your power source in the middle, and then you can choose normally open or normally closed. Normally open would be if the relay loses power, you'd want it to be always on. So if you were to lose control, you could either have it on or have it off. Personally, my rule of thumb, unless I really have an exception, is always to have it on normally closed. So if my relay dies, something burns, not sure, the Arduino turns off, I lose power, whatever it is, it always goes to normally closed and closes the connection to whatever it's activating. So instead of having a lamp go on permanently because the relay or something there broke, it would just shut off the lamp and it would stay shut off, and then you would know there's a problem. Personally, that's what I'd rather do. It's pretty much the default state of the magnet. So that's pretty much it for how it works. Now let's go and actually connect it up to a little circuit and make it happen. I'm just gonna use a light here and a little resistor so that the light doesn't get burnt out. And we're gonna plug in everything here so that we can use our relay to switch this light on and off. You're gonna need a couple cables. I just have different colors. So we'll use red, black, and purple for our power side. Now, since we're using low power, we can use these smaller cables, but if you were to activate something like a lamp, a fan, whatever, a microwave, whatever it is, you wanna use some big chubby cables that won't just get burnt out for any high amperage use. Okay, and then we're gonna have these three for connecting our relay. So our relay has a signal, a positive, and a negative. Signal is to turn it on and off. So that's gonna be orange, then we got red for positive, black for negative. I'm gonna plug in my red into the 5 volt right here. I'm gonna plug in the black into the ground right next to it. So now the relay has power, but no signal, so it's just gonna stay closed. Then we're gonna plug in our signal cable to 7. And look at that, it's freaking out. I think it's because I have some code on it that might activate a relay. So let's just go quickly on the computer. Okay, now that's been fixed. So we plug in our signal cable, we're gonna plug it into 7 on the digital side. So I'm gonna take a little screwdriver, you might need one of these. Just gonna open up all the terminals. Black is going to be our ground to the board, and that's actually gonna be grounded through our LED. Because remember, we're diverting the power into the relay, blocking it until we want to open it, but then the power has to continue and go somewhere else. So we're going to be grounding it to the board. I would not do this if you were powering something high powered, but because it's an LED, it's fine. Typically this ground would be going to a legit ground from a serious power source if you have to power something like a fan. All right, so now we're going to take our red and we're going to put it in the common. That'll just be a good way to know that's where the power is going. I should be using 2 red cables, but I don't actually have another one. Then purple is going to be going into normally closed, just this one. We can try after doing the opposite so you guys can see what happens. Now, our red is from our power source. So again, we're gonna pretend like we're powering from something serious. In my case, I don't have another power source. I'm just looking, there's a 5 over here. There we go. And then our purple, which is normally closed, is going to go to our LED. So this should not turn on the light. Oh, so we have something wrong. Something is not right. So I'm gonna take out power in the relay. The light's staying on, which tells me that I plugged into the wrong side, because that's got to be normally opened. Now if I just touch it to this side, it should not turn on. There we go. Okay, so I just plugged into the wrong side. So that's what happens when you use the normally opened instead of the normally closed. Now we're normally closed, and even though power is plugged into the relay, if I unplug the power, the magnet still stays in its default position. All right, here we go. Plug that back in. All right, so just to go over everything, we have our signal, power, and ground for the control side. We have our input power, and then it goes into the relay, and it goes to this resistor LED setup, and then it grounds into the board. All right, so let's open up our OBS, and then we can write some code to make this work. All right, so like always, the first thing we have to do is declare our pins. We only have one that we really care about. It's going to be our input pin, so I'm just going to put that as 7. And in our setup, we have to say what that pin is, so we got to do this pin mode, and inside pin mode, we got to call pin, and we're going to say it's an output pin. Then in our loop, we have to do something with the pin we just declared, and now since it's an output pin, we're going to write to it. Instead of digital read, we're going to digital write. And then in there, we can say what pin we want to write to, and then we want to tell it to go into low mode. Low just means off, high means on. So if the relay is in low, the relay should not work. If the relay is high, it should work. We're saying low so that if it is already high, it's going to be turned off. It's just a good practice. Then we'll do a little delay of 300 milliseconds, just enough to flick the light on. And now we're going to tell it the total opposite, which is going to be high. So it's going to make sure it's off. It's going to wait 0.3 of a second, and it's going to turn it on. And we can leave it on for, I don't know, maybe a whole second. So on for a second, off for 0.3 of a second, and then repeat over and over and over. I'm going to save that. I'm going to make sure that you're in tools here, you select the board you have. Mine's a Arduino Uno, and then the port, which is COM3. Usually just play with those and it'll work. So you click upload. I do not want to do that. Something happened here. I used the wrong. Okay, now we just enter that. I do not want to save it. So it's going to say compiling sketch, uploading. Give it a second here, and there we go. Make sure that the camera can see this. And you can feel it. Like I'm holding it, you can feel the tap. It would be enough to... Yeah, I mean, I could feel it all the way through the screwdriver. I could feel it through the table. It's pretty strong. You can feel that magnet going back and forth, back and forth. And then because of that, our light turns on. Now let's go in the code quickly and let's comment out everything except for the digital write high. So when I refresh this and it uploads to my board, it's just going to leave the relay open. Okay, so now our light stays on and our relay stays permanently open. We're going to go in here quickly. We're going to unplug our normally closed, and we're going to put it into normally open, which is now going to reverse everything. So if you wrote any code, you're going to have to turn it around, because watch what happens. You can see the light's on, the relay is opened right now, but the light is off. Now I'm going to unplug the relay. It's not going to have any power. Look at that. The light turns on because this is the default state of the relay. We're inside normally open right now so that it's normally open. So hopefully that makes sense. If it does, please do me a favor, give the video a like and subscribe to the channel so you can see more of these reviews, builds, explanations, whatever you want to call it. I will see you in the next one.